Hello all, thank you for tuning into this video focusing on random data for reproducible examples in Python Pandas. So what are reproducible examples? This is a concept used in programming and as well as data science where users are seeking help on the code. Their code is yielding errors or undesired results and they're seeking help both within their teams, co-workers, colleagues, classmates, or online via public forums such as GitHub or Stack Overflow. And the reproducible example really consists of two components: a coding section, essentially the lines that really generate the issue at hand, and this ideally is runnable, compilable with all the necessary environment packages loaded and assigned. And then the data component. This is for all the data available, be it data frames, arrays, to scalar objects, and so on and so forth. But then the users will run into a problem, right? Data can be proprietary or contain confidential information that they cannot easily disseminate even within their organizations for individuals who aren't privileged to that information or via online forums. So the data kind of has to be anonymized or scrubbed in a way. And so this the top focus of this video will be on randomly generating data that resembles the same structure as the actual data in order to fulfill the data component of the reproducible example. And just to show you, to illustrate this approach, we'll use an example data set from the U.S. Department of Energy, EIA data set. And this is pulled from their monthly energy review of total energy across sectors and aggregated the year-month granularity. And so this shows you it's about 6 columns over 7,000 rows. Here's the first 10 rows and last 10 rows. And it has a variety of data types. It has an object type, string type. It has integer values, numeric values with decimal point precision, integer again, and then a longer text format types. One thing to note that this is a panel model, right? This is sector data across time, so it's tracking a group across a longitudinal time frame. And another thing to note is that the MSN column corresponds to the description column, so these are one in one. This is essentially the smaller code value and the larger descriptor. One thing to note, we're going to assume that this data is proprietary. And so, but had it not been proprietary, we can easily run the data frame to-dict call, which is analogous to JSON, which really just dumps a dictionary output of the data. That an end user, the user seeking help from, can easily load into their environment and it can regenerate that data as is. But we can't jump to this step immediately, right? Because these are proprietary, confidential information we're assuming, and so we need a workaround. And so here comes the approach of randomizing the data to recreate the actual data structure and content for the reproducible example needs. First step you want to do is you want to assess the existing structure of your actual data. The dtypes call can quickly output all columns in their types. As we can see here, we have 3 string object types, an integer, float, and integer again, 2 integers and a float column. And then we can, with the describe call, we can look at the distribution, and this will be helpful when we run a couple of random generators that we want to keep in the same range between the same min and max, and even we can go even drill further with the same central tendencies with mean and medians. So that's a great assessment for the numeric columns. For the text columns, we can output unique, and we see here 11 values for both. Again, these two correspond with each other, and they all represent the different sectors and across either primary or total energy. So with this information in hand, we can then start running our random generators and sampling algorithms. One great feature of NumPy is that it has a broad range of generators, specifically using the randomized approach or even still others, manipulating arrays, either repeat values or even runs along sequences. For character categorical columns, you'll want to use the random choice call. You could even use permutation if you want to get a little deeper of possible combination pairs. Integer numerics, you could use the random integer functions, or run off various distributions, and put various parameters so you can replicate various specs to that distribution. If you want to repeat values, there's the nice handy repeat call, and there's tile. It'll take a vector and repeat it along x many amount of times. Sequence runs across integers, space between one or two values, or you can even in Pandas has a specific nice data generator, and you can even specify the frequency of that if you want days, months, years, and so on. And so we're going to use a few of these example random generators for our mock data set that we're going to replicate. One thing you want to do before you run any kind of random sequencing generation, you want to set the seed, and so NumPy random seed, and just pass in the integer value. This seed allows us to reproduce the same exact values the next time we run the code. As you recall, this was a panel model, so it has a time series element and then a grouping element. And what we're going to do is we're going to pull from the iterTools product. We're going to build all possible combinations between two series lists. Here are the date range values, and then our grouping, which is really, we're going to run generic groups of A, B, C, D, all the way to K for all 11 groups of the original data set. And then we're going to generate, pass into the data frame constructor, and then from there assign values, new columns, namely the value and the description column. For value, we'll run the uniform distribution, great handy tool that you can specify the min and max to keep within that same range, and then just specify the length you want that final array that's then binding into a data frame column. And then description, recall it runs parallel with the MSN column, so we'll need 11 groups that run correspondingly. So we can use the tile, NumPy's tile call will generate a list of groups 1 through 11 padded with this for the single digits, and then specify the length that we want to run it X amount of times. And so then we can finally get a nice generated data set here showing the first 20 rows. As you can see, A corresponds with group 1, A with group 1, and then it runs off each month series. So we essentially just scrubbed the entire data with random generated sequences and kept with the same range of values that we can then be safe to disseminate this with our reproducible example and not infringe on any confidential agreements. And then you can call that nice tidy toDict call, or again toJSON. You just print it out on your end, copy and paste, and include it into your reproducible example. Now the end user will then have to assign it, and for a special for the timestamp columns, you'll need to import, the end user will need to import this call. So maybe in your reproducible example, you can set this up, and then right before your coding lines for to really encapsulate your reproducible example overall. So hopefully I was able to really illustrate one alternative solution to overcome the proprietary and confidential nature of data that you need to include with your reproducible example. Thank you so much for your time.